Hi, college prep geometry. Happy, I don't know what day this is. I think it's day 3. All right. So we are moving into section 8.5, which is the law of sines. If you didn't take the quiz on yesterday's material of angle of elevation and angle of depression, please pause me right now and go take that quiz. And then don't forget to take the quiz on this stuff tomorrow. If you're overwhelmed with your workload, please give that daily expectations for my class a look, just so that you at least know what I want out of you every day and you're not totally overwhelmed and turning in stuff late. All right. In the name of the Father, and of the Son, and the Holy Spirit. Amen. When times get rough and I stress out, Lord, enter my mind and calm me down. Give me the strength to focus and concentrate and to do the best that I can and more. Give me peace and help me in making decisions. Lead me to the right choice. I really want to succeed, but I am still nervous and scared. I know the material. Shepherd me from stupid mistakes. Give me the power to triumph. I know I can. I know I will. I know that with you by my side, I am bound to persevere. Amen. In the name of the Father, and of the Son, and the Holy Spirit. Amen. All right. So, law of sines is using trigonometry to solve for triangles that are not right triangles. So, meaning Pythagorean theorem is off the table here. I cannot use a squared b squared equals c squared. It's not going to work. That's only for 90-degree triangles. So, law of sines is an extended proportion that tells me the relationship between the angle and the side across from it, right? Because when we name our angles and sides, if this is angle A with a big capital letter, then the side across from it is little a, right? So I've got big C, big B, little b. So law of sines is an extended proportion. I need 2 of them only to solve it. Best way to go through law of sines is by example. So I'm going to try to scroll just a little bit so I still got that picture. All right, so most of these problems are not going to give you a picture, so you're going to have to draw it. I was trying to play with this before, so my pictures looked a little less wonky. So I draw whatever triangle. It does not have to be to scale. It doesn't even have to really represent the numbers that you're doing. The only reason we're doing it like this is so that I make sure I have the right angle across from the correct side and that I'm filling in the right pieces. So even though the question here is only asking you to solve for the length of BC, normally when I assign these for on tests, I just asked you to solve the entire triangle. Tomorrow, I'm going to go through the law of cosines. Those 2 formulas work hand in hand. So if you know if you're given enough information to use one, then you sort of work your way towards the other. So it's just easier to just give you one triangle to use both formulas. All right, so in this triangle, I've got side A, I've got angle B, and I've got angle C. And the information that they have given me is that the measure of angle A is 48, which clearly should have a degree sign. The measure of angle B is 93. And then the other piece of information they give me is that the length of AC, which is this guy down here, is 15. All right, so they're asking me to solve for the length of BC, but like I said, we're going to solve this entire triangle. Okay, easiest part first. I did that activity with you guys ripping apart a triangle so that you would never forget that all triangles add up to 180 degrees. So if I've got 93 degrees and 48 degrees already spoken for, the measure of angle C has to be 39 degrees. Okay, so that's part of it. When I ask you to solve the whole triangle, I want all of the missing pieces. So the measure of angle C is a missing piece, so there's part of it. I'm also going to need to know what little a is, right? Because I don't know the side across from the 48. So I've got a little a, and I also am going to need a little c. Sometimes it's hard to differentiate between a big C and a little c. If you want to get extra to make that thicker or whatever, some way that you can indicate. Obviously, I know where your answer is because the big letters are degrees and the small letters are the lengths of sides. So no degree sign. All right, so I am setting up my extended proportion. So I'm going to use the only complete fraction I have is this 93 and the 15 across from it. I can't solve this if I have more than one missing piece. So I need to use an entire fraction. So it looks like I have to use the sine b over b because that's my complete piece. So that means my fraction's going to start, or my equation is going to start with the sine of 93 degrees over 15 has to be equal to. So eventually I want to solve for both AB and BC, right? So for little c and for little a, we'll solve for little a first. So if little a is over here, the angle that it matches up with is this 48 degrees, right? All of those proportions, that's super lopsided. All of these proportions have the angle and the side that comes across from it. That's what makes up every single fraction. So if I want to solve for little a, I'm going to have to use the sine of 48 degrees over my missing side. So that is the proportion that I have to solve. So give myself a little room. I can always come back. Let's not show you the next question. All right. So we spent a whole day in class working on remembering how to solve proportions. If I have one fraction equals another fraction, all I have to do is cross multiply. So I've got 15 times the sine of 48. And then when I cross multiply the other side, I've got a times the sine of 93. Now, I'm going to let my calculator do as much heavy lifting as I can. So rather than inputting the sine of 48 and the sine of 93 and then dealing with all these decimals, I'm just going to let the calculator do it. So I do have to isolate my a first. So since a and sine 93 are attached by multiplication, I'm going to divide both sides by the sine of 93. Okay, I know it might look weird to be dividing by what looks like a bunch of letters, but the sine of 93 is a number. So I'm just dividing by a number. It just happens to have more letters in it. So I'm going to divide both of these sides by the sine of 93. Okay, degree sine, degree sine, degree sine. Since I'm dividing something by the exact same thing, those two cancel out, leaving me with the a by itself, which is what I wanted. So on the other side, I have 15 times the sine of 48 divided by the sine of 93. I'm going to show you this on both calculators. Totally messed myself up as far as giving myself enough room to show you what I want to do. All right, so I kind of got it. My calculator is still in degree mode because this is the only class I'm doing trig in, and I'm not teaching any classes with radians. So I'm in degree mode because that's the mode that I need to be in. I'm still in it because I put it in that yesterday. If you didn't see the post, TI is giving away free licenses to this software that I use. So I would definitely download it and install it for free for 6 months, because what better way to learn how to use your graphing calculator when you're spending quality time at home? All right, so the fraction I was trying to solve is, so I want the entire 15 times the sine of 48. That has to be the top of the fraction. So I'm going to put parentheses around it. So I've got my 15 times the sine of 48. So when I hit the sine button, it put in a parenthesis for me. I need to close that parenthesis around the 48, and then I also need to close the parenthesis around the 15. So this is the entire top of my fraction, and I am dividing that by the sine of 93. Now, I mentioned yesterday we're going to get lots of decimals with these. Law of sines and law of cosines tomorrow is going to be no different. We traditionally round to about a tenth. You don't want to round too much, but a tenth is always a good spot, especially if it doesn't say in the instructions. When I eventually give you a Math Excel on this, please make sure you're looking at the form that they want it in or the decimal places they want. A tenth is one spot in. So that means A is about equal to, because it's, since we're rounding, so I'm about equal, I can turn those little squiggies, about equal to 11.2. That's my first value for that one side, 11.2. All right, so like I said, I want to solve the whole triangle. So I also need to figure out what little c is, this guy over here. Now, I now have more than one complete proportion. The reason I had to use the 93 and the 15 was that was my only complete fraction. Now I have options. I could use the sine of 48 over that 11.2, or I could keep using the 93 degrees and the 15. It really doesn't make a difference. Since we're rounding, if you end up using that 11.2 and 48 degrees, your answer might be slightly different than someone doing it the other way, but it's only because you're not using the full decimal, excuse me, and you're truncating it at some point. It's the only reason why the answer is a tiny bit different. But again, remember, you cannot use the Pythagorean theorem. That is only for right triangles. So if I want to solve for this 39, like I said, I'm going to use that sine of 93 again. So new fractions, same pieces for part of it. The sine of 93 over 15 equals, now I'm trying to solve for little c. So now I got to use the sine of 39 degrees over little c, because that's what I'm trying to solve for, okay? So they look very similar, okay? When I'm trying to solve for little a over here, I use the 48 that came right across from it. So when I'm trying to solve for little a, I had to use 48, okay? They go together. When I'm trying to solve for 39, or when I'm trying to solve for little c, I have to use the 39. They go together. But I can repeat that complete fraction that I started with each time. All right, same exact thing. This is why we spent a whole day on remembering how to solve our ratios. I need to cross multiply, so I've got c times the sine of 93 degrees is equal to 15 times the sine of 39. I like to put the number I'm multiplying in front, especially for those of you that are a little bit sloppier. This reminds me that it's definitely multiplication, and I don't have this like weird sine 93c. It's c times the sine of 93. Just like before, I need to isolate my variable, and since c and sine 93 are connected by multiplication, I can divide it away. 93, and same thing, sine of 93. Again, I'm going to let my calculator do all the heavy lifting. So these two canceled each other out. So C is going to be equal to whatever this mess of a fraction equals to. So if you don't want to use the simulator, even though I think you should, my scientific calculator will also do this in Desmos. So again, we make sure we're in degree mode. And I didn't practice this ahead of time, but I'm sure it's going to be fine. So I've got my parentheses to separate the 15 times the sine of 39. Closing off. It even tells me what to do because Desmos is that easy to use. And then I want to divide all of that. And when I hit the divide button here, it does give me that stack fraction. So I know that I'm doing this right over the sine of 93. I don't actually have to close that parenthesis, but I get about 9.5, right? If I round to the nearest tenth, this 5, if I round to the nearest tenth, the 5 kicks the 4 up 1, so that's why the answer is 9.5. So let's see how much I can spastically move the mouse around the screen. That makes C about 9.5. No, I'm not going to be nitpicky if you make those equal signs and not the wavy lines. So the complete answer for solving the whole triangle is that big C is 39, little a is 11.2, and little c is 9.5. I realize that this question only in the textbook asks for BC, but it's not like you can ever do too much math. Yes, I realize I'm biased on doing too much math. All right, this one's a little bit different. Okay, so for the first one, spastically moving the screen back and forth on you. If you remember back to our triangle proofs, the example that we just did, I could technically consider it as angle side angle, which is a totally legit, right? Because if I use the third angles theorem to give that 39, I have an angle, a side, and an angle. The next one isn't. So I'm going to do the same thing. I'm given a question. I'm not given a picture. I'm trying to solve for just one angle, but we're going to go overboard and solve for more. If I draw the triangle out, Now, these variables are different, right? They didn't give me ABC, they gave me RST. All you need to know for the law of sines is that you need to have the angle and the side across from it. That's it. It doesn't matter if it's an A, if it's an R, it's still the same thing. But I want to make sure I label this consistently so I'm not. I mean, if you really wanted to rename this triangle ABC and then change all the letters accordingly, that would work too. All right, so I've got A, B, C. I'm given that RT, and then I didn't even listen to myself. So let's try that again. All right, so make this R. Did you think I was going to make less mistakes because you're all not in front of me distracting me? I just don't have you to blame for my mistakes. All right, so RT is the side down here. That's 11. ST is over here, and then I have the measure of angle R as being 120 degrees. It doesn't matter that I didn't draw this like an obtuse triangle, okay? I drew this so I've got the angles in the right spots. Do not worry that when you draw it, you don't have something that looks like 120 degrees. Okay, so if this was a pre-cal class, I would spend the next 40 minutes talking about special cases and how there are times when a triangle doesn't exist and you need to do all these test cases. And it's just as much fun as it sounds like. This is geometry, though. So we are only worrying about the case where there is one triangle. When you talk about this even if you do Algebra 3 next year or if you do pre-cal next year, this actually is a much more complicated problem than I am making it. There is special cases, and if you remember back to those proofs, I have this triangle is technically a side angle, which you all know I can't use side angle for proofs, right? Because if I just flip the direction, it spells out a word I can't say. And this is not a valid way to prove that two triangles are congruent. The reason it's not valid is because of all these special cases. We aren't worrying about that here. I realize this is an angle side triangle, but I'm only going to give you the cases where this actually works. And there's only one case, not no cases or two cases. So after I rambled on about all that, I still need to use my complete proportion. So I've got the 120 and the 18. So that's the only piece that is complete. I have to use that in solving or starting to solve my law of sines. So that means the sine of 120 degrees over 18 is going to equal. So now I get to choose. Actually, I don't get to choose. The only other piece of information they give me here is the distance of RT, which since it's across from S, that's going to be my little s. So in my fraction, the 11 is going to go underneath the sine of S. As far as the proportion being set up, it's exactly the same as what we did above. I am cross multiplying to solve. So I've got 11 times the sine of 120 equals 18 times the sine of S. Now the difference here is I don't know the angle. In the problems before, I just plugged everything in. I let my calculator do all of it. I'm still going to plug everything in. But if you remember from the lesson yesterday, if I was trying to find an angle, I had to use those inverse functions in my graphing calculator for sine, cosine, and tangent. I'm going to do the exact same thing here. But again, I'm going to let my calculator handle all of it. So first thing I have to do is separate the 18 from the sine of S. Since they're multiplied by each other, I am just dividing. I put all this on the wrong side. I set this up so the calculator would be right there, and I made my life so much harder. All right, so the 18s cross out because it's the same thing on top and bottom. I've got the sine of S is equal to this 11 times the sine of 120 divided by 18. I don't want all of this. I want to know the sine of what angle gives me all of this, but I still need to figure that piece out. All right, so I'm going to do this in the graphing calculator because I'm more familiar with it. But again, I'm still in that degree mode. I'm going to make this a little bit smaller. All right, so parentheses 11 times the sine of 120. I close the first parenthesis for the sign. I close the second parenthesis for the top of my fraction, and I'm dividing that by 18. When I hit enter, I get this monstrous decimal, okay? So for the sake of your notes and understanding this a little bit more, I am going to write that decimal out. When we are dealing with trying to use these decimals and inverse functions, rounding it to just a tenth isn't going to help you. Your answers are going to be way, way off. Turns out sine and cosine all range between 1 and -1. So rounding really messes your angle measurements up. So we want to have it to at least 4 decimal places. That's traditionally what I do. So the decimal I just had was that this was equal to 5292. So especially if you're using a lower calculator, you're definitely going to need that 4 decimals written down, especially if you want to get partial credit from me. All right, so we talked about in our last video that I want to be able to separate this, I need the inverse function. So the inverse function of sine is sine to the -1. Yes, there's this thing called cosecant. We won't worry about that at all. All right, so I'm taking the inverse sine in front of both. So the whole point of taking the inverse sine on this other side is to get s by itself. That's what I'm looking for. So I need to take the inverse sine of this 0.5292. But remember how I said I was going to let the calculator do all the heavy lifting? If I want to take the inverse sine, so remember, calculator's color-coded, sine, cosine, tangent. I know I made it teeny tiny. But I want to take the inverse sine. My number that I want to take the inverse sine of is right here. It's this big monstrous decimal. If you look above the negative sign, it says ANS in blue. Second ANS. What I'm telling my calculator to do is I want it to take the inverse sine of the very previous answer, this 0.592. So I don't have to type that decimal in at all. I don't have to truncate it and round it. I can literally type it in just like that. And my answer, even if I round it to 1 decimal place, the 5 kicks that 9 up, right? So this becomes 32 degrees. 30, I lost my pen, 32 degrees. Okay, so let's go back to my picture. Put that 32 in, right? Because the whole point of drawing the picture was so that I could make sure that I'm matching the right answers up in the right spots. So I know the measure of angle S is 32 degrees. Okay, and again, oh look, it's almost like that whole triangles equal 180 degrees is like important or something. If I have 120 and 32 degrees already spoken for, the measure of angle T has to be 28 degrees. Nothing fancy, no law of sines, straight up subtraction. That means the only other missing piece I need to find is over here, my RS or little t. So again, choice is yours. I now have 2 complete proportions, so I can use either one. I can use the 32 and the 11 or the 120 and the 18. Doesn't make any difference. I like to always use the one that I had to start, but that's just me because I'm a big weirdo. So I've got the sine of 120 over 18 is equal to, so now I want to find little t. So I have to use the sine of 28 to get there to solve for that side across that little t. So now we have all the angle measures again. I don't have to worry about that whole inverse sine stuff again because I only need to find the sides. Still going to cross multiply. It's almost like that lesson was important. Sine 28 equals t times the sine of 120. I want to solve for t. Ooh, that's good and lopsided. I want to solve for the sine of 120. Trying to separate my stuff out. So I divide both sides by the sine of 120 in the most lopsided division line ever. Sine of 120. I was allowed to do that because sine of 120 is just a number. So I've got same thing over same thing, which gives me my t by itself like I want. So I need to put this 18 times the sine of 28 all divided by the sine of 120 in my calculator. So I'm putting lots of parentheses. Yes, I realize there is another work away, but I'm trying to be consistent. work away, work around. 18 times the sine of 28, boop, boop, divided by the sine of 120. Close that parenthesis. And I get, again, rounding to a tenth, 9.8. So the measure of little t is 9.8, about, when I round to that nearest tenth. So the complete answer is that t equals 9.8, or little t equals 9.8, big T equals 28 degrees, and big S equals 32 degrees. Give this a thought also, right? I said, if you learn nothing else in my class but to use that thing that floats around between your ears, I'll be really happy. Even though I can't use the Pythagorean theorem, there's still things that we've talked about that, like, if I spend 10 seconds thinking about my answers, that maybe I'll catch a mistake if I made it. 120 degrees is the biggest angle in this triangle, whether I drew it like that or not. That means the biggest side of this triangle has to come across from it. So it's a good visual check of, okay, well, my biggest angle is 120. Okay, 18 is my biggest side. That goes together. My smallest angle is 28 degrees, and 9.8 is my shortest side. It makes sense. It logically connects. Don't ever not spend that 10 seconds just looking to make sure your answer makes sense. All right, so quiz on this stuff tomorrow we'll post. You'll have all day to do it. If you're having any trouble managing your time or your expectations, please don't be afraid to reach out. If you have any questions on this stuff, please write them in the comments below, and I will be happy to address it in another video. I will talk to you guys tomorrow.